Section 3.2, we go into how we solve equations without graphing. Because graphing is not always the best way. It can be helpful sometimes, but honestly, other ways are faster and easier. You don't need graph paper for them. So we're going to go into our two methods of solving a system. There is substitution and there is elimination. So we will start with substitution. The steps for substitution are solve for one variable in one equation. Then you substitute into the second equation and solve. And the last one is you substitute the value from step 2 to find the other variable. And that might not make a lot of sense until we actually do it. So if you need more time to write, just pause and write down those steps, and I will continue on to number 1 and 2. So number 1, we have to solve for a variable in one of the equations. I recommend picking with the equation that's got a letter by itself. So like you see how there's just x. It's not like 2x or 3x or 3y. It's just x. So let's take this equation and solve for x. How do you get x alone? You have minus 2y. So you end up with x equals 6 minus 2y. This is what we wanted. So that's step 1. Solve for a variable. So we solve for x. Step 2 is you take what you got. So we solve for x, and we got x equals 6 minus 2y. You take your second equation and you plug that in. So it's 3, and then instead of x, we say 6 minus 2y. Minus 2y equals 2. So you see that? We took this and substituted in for x. So it's, instead of 3x, it's 3, 6 minus 2y. Now we solve for y. So distribute 18 minus 6y minus 2y equals 2. Combine like terms. 18 minus 8y equals 2. Get y alone, so you minus 18. Negative 8y equals negative 16. And then we got to get rid of the negative 8. Whoops. So divide by negative 8 on both sides. That will cancel out the negative 8s. So you end up with y equals positive 2. So the whole reason we did that is because you see the highlighted part up here? We were able to plug that in for x, and now in this equation right here, the only letter we have is a y. If we only have a y, we can solve for y. But when you solve for y, you'll find out y equals 2. So once we get y equals 2, that was step 2. Substitute into the second equation and solve. We solved and we got y equals 2. Now since y is 2, we go back to here. If y is 2, that means x is 6 minus 2 times 2. So x equals 6 minus 4. So x is 2. So x is 2 and y is 2. And if you want to double check, you can plug them back in here and make sure they work out. 3 times 2 minus 2 times 2 is 2. And then in the second equation, 2 plus 2 times 2 is 6. So that one works out. Okay. Let's try number 2, one more example like this. So we want to solve for a variable to start. I'm going to take the first equation. X minus 2y equals 3. That's the easiest one because like I said, if you have a letter by itself, pick that one. So if you want to solve for x, you would add 2y, and you will get x equals 3 plus 2y. This is what we want. We want to get one of those letters alone. So now if you look, what does x equal? X is 3 plus 2y. So we take the second equation, 2, and you're going to put in 3 plus 2y minus 4y equals 7. So notice, oops, I need to undo that. Notice 3 plus 2y goes in for x in the second equation. Now we solve for y, because the only letter left now is y. So it's 6 plus 4y minus 4y equals 7. Okay, 6 plus 4y minus 4y equals 7. If we combine like terms, what's 4y minus 4y? We get 0. So they cancel out, which can happen. So we're left with 6 equals 7. Does 6 equal 7? This is not true. So I gotta erase. This is not true. So if it's not true and the variables cancel, we end up with no solution. The variables cancel, we end up with no solution. Again, this symbol would work just fine too. Okay? So that is substitution. Solve for a variable, plug it in. You get the same variable twice, so like you get just y. You solve for y, and you solve for x. And special case would be like number 2, where if you get 6 equals 7, because everything cancels, if it's not true, it's no solution. Elimination is our second method. Elimination, which is also called linear combination. In this one, we line up both equations and you multiply so one variable is opposite, and it's going to cancel. Okay, so line them up. So let's look at the first example down here. Let's do that. Let's line them up and multiply so one of the variables will cancel. So do you see, when I say line them up, I mean like, you see how the x's, the y's, the equal sign, and then those numbers are all lined up? That's what we want. We want to make sure one of them will cancel. So like, I'm going to pick the y's. What will cancel with a positive y? A negative y. So if we take the top equation is a plus y, we want to make the bottom equation into a negative y. So if you take this equation, how can you change y into negative y? You'd multiply. So you multiply it by negative 1. So negative 1 times x is negative 1x. Negative 1 times positive y is negative 1y. And negative 1 times negative 2 is negative 2. So these equations are added up. They're lined up and added up. So when you get negative 2 plus negative 1, you get negative 3. And 1y plus negative 1y, this part cancels. So you get nothing. It cancels out. This cancels out. Then we have our equal sign, and 5 plus negative 2 is 3. So the reason we did that was we eliminated the y. We got rid of the y. So we actually did step 1 and step 2. We lined up the equations, and you multiplied them so that a variable cancels, and then you cancel the variable and solve. So we canceled the y, and now we got to solve for the x. So how do you solve for x? We got to divide by negative 3. So you end up with x equals negative 1. So you cancel the x, you solve for y. Once you solve for y, the last part is to go back and find x. So that'd be step 3. You substitute the variable back into the equation and you solve. So you take this variable and you plug it back into one of these. I'm going to plug it in the first one. Instead of x plus y, now it's negative 1 plus y equals 2. And then you solve for it. How do you cancel out a negative 1? You would add 1 to both sides. So the 1 will cancel and you will get y equals 3. So that would be elimination. So elimination, I think, is actually quicker and easier than substitution, but they both work the same. You don't need graph paper. You can just solve for the variables. and I will do number 4 with you, and this is the last one. So we have a 6x and a 15x, 10y and a 25y. We need to pick one of those to cancel. I'm going to look at the 10 and the 25y because those numbers are easier for me in my head. What can 10 and 25 both turn into? Because 10 can't turn into 25, but they both can turn into 50. So I'm going to make the top one into a negative 50. So times everything by 5 to get 30x minus 50y equals 5 times 12 is 60. The bottom equation, we need into a positive 50. How do you change 25y into positive 50? You multiply it by 2. So negative 15 times 2 is negative 30. 25 times 2 is positive 50. And negative 30 times 2 is negative 60. So we lined them up. The y's are opposite. Now we got to add everything up. 30x plus negative 30x is 0. Negative 50 plus 50 is also 0. 60 plus negative 60 is 0. So we end up with 0 equals 0. Okay, this is a special occasion because remember the last time we did this? The y canceled up here. The y canceled and we solved for x. Now the x and the y both canceled. So if we scroll up, when we got something like 6 equals 7, we said that's not true, so it's no solution. But what happens when we get something like 0 equals 0? This is true. So instead of no solution, this is infinitely many. You can also write this infinitely many. So that's when we know it's infinitely many solutions. So there's no solution, infinitely many solutions, and then sometimes you just get what x is and what y is.